Hi, welcome to York County Community College's Sanford Instructional site. My name is Kate Grant, and I'm here today with two of our faculty members who teach at the site, and I'm going to introduce them to you. I'm going to flip my camera around here. So we're going to start in the classroom today, so you can see what one of our classroom spaces looks like. Then we're going to go out into the floor and give you some demos of some of the equipment that is here, the machinery, and talk to you about a couple of our different program options that we have, as well as some of the careers that are connected with them. You'll notice that we'll all are masked up and wearing PPE so that we're being safe during COVID. All right, so I'm going to start over here with Jake. Jake, do you want to introduce yourself?
Hi, my name is Jake Sullivan. I'm the full-time instructor here at the York County Instructional site, the Sanford Instructional site. I teach all the PMT programs, the machining, the turning, the CNC, the metrology, all the core classes for the PMT program. I have experience machining in an aerospace environment, as well as programming fourth and fifth axis machines in a commercial skylight company. So we look forward to showing you the place.
All right, hang on, and here's Bill.
Hi, I'm Bill Frederick. I am a graduate of YCCC. My duties here are many of the manual programs, manual machining. I've done that in my professional life, remanufacturing, making one-off parts and that type of stuff. I'm also involved in SolidWorks and the additive manufacturing program. And I'm usually either out in the front office or right out on the shop floor.
Awesome. Okay, so I'm going to zoom out so you guys can all see the classroom space here before we head out onto the floor. So can you guys talk to me about what kind of classes are taught in this classroom space?
So all of our machining classes start out in here, especially in a normal non-COVID environment. We all start out here. We have anywhere from, depending on the content of the day, anywhere from a 15-minute to a 45-hour-long lecture about what we're going to be doing out in the shop. We introduce new concepts here and go over, review past practices. And so all the manual machining classes start in here. The CNC classes, we do a lot of work in here. Every student has their own computer. So there's a lot of programming that happens at the computer, and then you would take your program from the computer via a USB drive to a simulator or to a machine to simulate the program and or run it on the CNC machine. In the second year, you can see on the screen we have a CAD program just kind of playing a animation. So in your first year, you would take a CAD class with our CAD department, teaching you how to draft parts in SolidWorks. And your second year, we teach you how to take your CAD file and run it through what's called the CAM system. And the CAM system generates all the G&M code so that the CNC machine can actually manufacture your part in real life.
I'm going to zoom in on this because it's really cool to see the movement. You can't quite see
that.
On my phone.
That is actually our second year students project this semester, is we're building a 6-cylinder air-powered radial engine.
That is awesome.
All
right.
When we go out to the floor, we'll actually show you some of the parts we're making for it.
Awesome. Are we ready to go to the floor?
We could do that.
All right, let's go. I'll follow you guys out.
These computers are pretty powerful. These programs require a bunch of thinking to take place. And they're loaded with the same software that we use down on the Wells campus to do many of the art and 3D graphics programs. Because as we go to additive manufacturing, that software from the Wells campus works just as well as this for making additive manufacturing parts.
Awesome. All right, great. Let's go. So I apologize if this is a little bumpy for those of you watching. Try not to make you seasick. All right, so we are now on the floor, and I'm going to kind of do a span here so you get the big picture. So as you can tell, it's exceptionally clean. This is not usually, I think, what most people think of when they think machine shops, but precision machining and additive manufacturing are a little bit different. All right, so we are going to try to enunciate as much as possible so you guys can hear us still. And we're going to do a little bit of a tour about some of the machinery here out on the floor.
First, Bill's going to talk about the additive.
Right.
So in our additive manufacturing, you might know that as 3D printers. And a lot of people have had MakerBots in their educational experience in the past. So that's a good start, but our machines are industry grade machines. The one behind me prints with a filament. One of the materials it prints with is a nylon that's carbon fiber reinforced. This is something you'd see out in industry. This fixture actually goes in one of our CNC machines and helps air and coolant get out to cool the tools and clear the work while we're running. This machine can do a lot of strong, real strength, a lot of prototyping. We got some real fixtures there on the table, and it prints in several different materials, not just carbon fiber. So we printed some frames for face shields due to the COVID thing. This is an ASA. Material holds up real well out in the sunlight, doesn't degrade. This is a high strength fixture that would have been manufactured from aluminum or some other metal for production purposes. It can be remade in the course of a few hours during the night if we want to redesign it. If you had to go out in the world and rebuild the file and reprogram a CNC machine to make a new part out of aluminum, that's more like a whole day long process instead of 1 hour or 2 hours. Some of our other machines print in other materials. We have a resin machine next in the lineup. And so this machine prints with fluids rather than a filament. It can do many different colors all at the same time. It can do many different materials. This part that I'm holding in my hand is a hard plastic and a soft rubber, and it prints this all at once. It's a little drive wheel fixture for conveying systems. But that technology, this is industry grade equipment and something that you couldn't do in the past. There's many operations combined into one short time period. The other thing that you might do is manufacturing molds for industry. This was printed in a Connex machine, just like the one that we're in front of. And further down, we have another filament printing machine. Actually prints in 4 different materials, 4 types of filament. So each one of these machines has a larger build chamber, and it is something that you would see out in industry. It's the beginning of our additive program.
All right, so we've checked out some of the additive equipment, and now we're going to go onto the floor for the other part, and I think Jake is going to take us there.
Yeah, we'll walk through the machine area right now. You can hear we have a 3-axis mill running over here. You can take a look inside real quick. And this is a proven program. So once the program is proven out, you can just load the part and let it rip and keep making parts. And we're making these little features right here. See, it's a pocket, the pocket inside of it, and the boss, filleted corner all the way around, rounded over corners. And our first semester, every student writes programs for some of them. You know, we start out really simple, a really simple little square part like that, and move on to more complicated things. But we take every single student through the process of writing the program, setting their program up, running a first piece on the program, and getting ready to actually produce if they wanted to mass produce something. So, yeah, we have 3 of these 3-axis machines, and every first-year student has been through these machines several times for several different parts. For our second-year students, we just got our brand spanking new Haas Umc 500. This thing's the Cadillac.
Woo-hoo! Look at that, baby. All right.
This is a full 5th-axis machine. So if you look in there, you can see that it's got a turntable, it's got a tilt and a rotary, and it just stopped at an M01. So if you look in there, you'll watch it all. I'll hit the go button. It's going to do a tool change. And then it's going to go in and it's going to start finishing off those pockets on the outside of that crankcase. And this thing's got everything. It's even got a programmable coolant nozzle that'll aim the coolant specifically at the tip of the tool. And you can manufacture all kinds of stuff in there. Right now, what we're doing is we're taking round stock like this, and we're turning it into a crankcase body like that. Drilling all the holes and milling all the pockets. And that way, they can mount the cylinders for the radial engine all the way around it. But yeah, this is something that all of our second-year students have the opportunity to learn. It's got tool probing, it's got part home probing, it's got...
He says with pride. You can tell this is a big deal.
All kinds of stuff.
That's awesome.
It's got features I probably haven't even discovered yet. All right, and then heading over this way. Along the back wall, we've got a full bank of Bridgeport type manual lathes.
All right, talk to me about the difference between these, like manual, and the ones that we just looked at.
So the CNC lathes are controlled by a program. You write the program, and the program changes the tools. The program moves the part around in space. The program creates all the features. These machines, you have to put the tool in the spindle yourself. You have to load the part in there, and you actually maneuver the part around in 2 axes and maneuver the tooling up and down in a 3rd axis, almost like an Etch-a-Sketch. And this kind of machining is what people use in tool rooms to make very precise one-off parts. It's what people who are doing maintenance work do when they need to make replacement parts where they're only making one of them. It's not high production, but it's very high skill. This is truly the more skilled aspect of the trade right here, is the manual machines. Our first-year students this semester are making a little mini mill vise as their first-year project. So has to be very accurate, especially the jaws and everything. It has to be able to sit on a flat surface, and the face of the jaws have to be perfectly perpendicular to the surface it's sitting on. They have to be perfectly parallel to each other. So it really tests your dedication to making high fidelity parts. So that's all of our manual milling machines. They're all set up, as you can see. We try to mirror best practices, like 5S practices that you would find over at companies like TurboCam and Pratt & Whitney and all these other large local manufacturers. Everything's laid out in shadow boards. Everything's very clean, very organized, very well kept. And we try to teach our students how to follow these practices that they're going to find out in the workforce.
Awesome.
Yep.
All right, where are we going next?
All right, so we can look over here.
Yep.
On the back side of our mill area these are our two CNC lathes. So again, these are lathes that students would write programs for, or they would create a program within the CAM system for. It's got a 10-tool turret up there and a high-speed spindle. All the tail stock in there. And they will turn out parts sort of like this, like these little chess pieces we've got here. I tell my students, you know, that your first semester, we tried to teach you how to make anything. Or not your first semester, your first year. A first-year student should walk away knowing how to make anything. By the end of your second year, you should walk away knowing how to make anything 10,000 times. I want 10,000 of these, and I want you to figure out an efficient way to get me those using, you know, as little waste and as little wasted time as possible. So again, in our first year, the second semester, that's when we focus on the CNC lathe manual programming. And we take all of our first year students through and they learn how to set up the machine fully. They learn how to program and run their own programs. They, really by the end of the first year, they've set up both mills and lathes, and they're very well prepared to take a job at a company like Pratt & Whitney or TurboCam or the shipyard or many of these other places. Yep.
All right, where are we going next?
So we're going to head back over here. And over here we've got our manual lathes. So much like the manual mills, these are all controlled by hand wheels. The movement of the cutter is controlled by hand wheels. And you know, we actually get a few people coming in just specifically to learn these because these are a fairly popular tool to have in a home shop. You can do a lot with just a lathe. But we teach you how to do turning, how to turn profiles, how to bore and ream on the lathe, as well as how to do threading on the lathe. Some of the projects we do, we make these little tap followers that you can put in your toolbox. We make these little machinist jacks that people use for one-off projects. We make hammers, machinist hammers of various sizes. And that is all in the second semester of your first year. And then obviously second year students use them quite a bit as well for their projects.
So I'm going to ask you a quick question. You talked about first year and second year. Can you talk to me about some of the different options for students, kind of depending on what their goals are? So if they just want to do a one-year certificate, it's really actually only, what, 8 months that they're actually in the classroom? Yep. Okay. So it can get done in 8 months. And for the precision machining operation certificate, what kind of job can somebody get with that? So they're here for 8 months. They learn these skills. What kind of job could they get? So
with a certificate like that, you could find an operator job at some of the local larger manufacturers. Pratt & Whitney hires people out of our certificate program. So does TurboCam. I'm sure Velux would hire people out of our program.
What kind of, can you talk about salary for some of those individuals? So they do 8 months. What kind of salary are they looking at?
A lot of my students who are first year, a lot of my students who are in the 2-year program are hired before they're done with their first year.
Sure.
And those guys are starting out between $19 and $20 an hour, with 4 or 5 weeks a year paid vacation, depending on where they're going, and healthcare and 401k and all the benefits. I mean, you can have a really great career with the certificate program. The associate's program is if you really want to advance in your career and you want to move on to something like being a tool room machinist or doing a lot of one-off type of work. If you want to be a CNC programmer specifically, which is what I was doing before I came to the school. If you want to move on further in your education and get a bachelor's in manufacturing engineering or in systems engineering or something, I say systems, industrial engineering is the word I'm looking for. If you want to move on to an engineering degree, it's a great foundation for all of those things.
Okay, great. Thank you. There's somewhere else that we're going to check out in here.
Yeah, we'll swing through
Okay.
around to the back of the shop, and then we'll stop off in the Metrology Lab. And I think that's it, right, Bill?
I think so.
Yeah.
I would add to what Jake said that the first year program is going to leave you with a very rounded experience of all the equipment that we have. So you could go straight to a big shop that's going to do a lot of CNC work over and over, and you're going to be recognized that you have the ability and recognize what's happening in the machines. But you could also take that out to a shop that's doing one-off work and maintenance work because you know how to operate this equipment. You don't have 20 years worth of experience, but coming in knowing how this machine works and what it's capable of is very key. And most companies that use them are going to wish that you had that knowledge rather than explaining all the base steps. They can give you some simple projects for this machine right off the bat, maybe not in the same pay scale, but over the years of developing the skill to run one of these machines in one-off work, just has different benefits it brings back to the employee. What kind of work do you want to do? But you can take all of that out of the first year. In the second year, students usually have the opportunity to work with all this equipment. And if they want to focus on the manuals more than the CNC, they will be able to make use of them. They don't just only write programs in the second year. You have to use everything. And that's part of the second year program too.
Yeah.
Let's continue on.
Over here we have our stockpile of materials that some of which are left over and some of which are dedicated to the projects that are upcoming. We get donations from a lot of the local
A lot of metal.
yeah, a lot of local manufacturers. One of the other companies that hires a number of our graduates is General Dynamics. I should not forget to mention them because they actually donate a lot of material to us. We have, that's a bandsaw that's used for rough cutting stock. Over here, this blue and gray machine that you see is a surface grinder. And that is the most precise piece of machinery we have in the shop that can grind things down to a tolerance of 1/10 of a thousandth of an inch. It's highly accurate. It's a real skill learning to use one of these. It takes a lot of finesse and a lot of practice. And then over here, we'll just step into our metrology lab. Metrology is just a fancy way of saying the science of measuring things. Once you've made something, you have to know if it's the right, if it's the right size, if all the features match the print. This here is a CMM, which stands for Coordinate Measuring Machine. And as you see, it's got this little ruby tipped probe right there. And this machine can go around and measure parts in 3D space. It can measure in 5 different axes. And it can tell you whether a part conforms to expectations or not. I can show you a little of how it moves. Once the program is set up, I'm just going to probe in that calibration sphere right there. And it comes in and it just touches off and it beeps off all the sides of it, and it measures it, and it can measure the size of the sphere, how round the sphere is, the location of the sphere relative to other things on the table. And again, it can position that probe in a number of axes. It's really a fascinating machine. And these are used a lot in industry. If you have a large production line with parts that have many, many features on them, they will have CMMs set up, and you will take the part off the machine, load it on the CMM, and run a pre-written program, execute a pre-written program to go around and measure the part and tell if the part is in conformance or not to tolerance. And then in the rest of the room, we have a lot of other traditional measuring type devices, down to the very traditional. I still like to teach my students how to read these, vernier type calipers with the vernier scale. There's no digital readout, no dial to read. You have to actually read the scale, kind of like an old slide rule. Have things like, bore gauges that we show our students, micrometers, dial calipers, dial indicators. We deal in measurements that are down to the 1,000th of an inch or less, sometimes half a 1,000th of an inch. We've got a manual CML, we've got surface plates, we've got height gauges. We teach people geometric dimensioning and tolerancing, otherwise known as GD&T, and we not only teach you how to read it on a print, but how to measure it in real life, how to measure things like flatness, parallelism, perpendicularity, all these kinds of things.
We've got several $100,000 worth of tooling in this room that you will know how to work with when you leave. And that's, not everybody has that,
All right, I'm going to do a quick scan around so they can see the whole shebang here.
Yep.
Am I making people sick? Oh, I'm sorry if I am. All right. There we go. All right, guys.
Yeah, so that's our facility. That's an overview of what we do. We'd love to have you come join us.
All right, so I'm going to flip the screen around so you guys can see the masked lady again. And if you're interested in finding out more information, please contact us at York County Community College. We'd love to talk to you. We can connect you with both Jake and Bill here at the Precision Machining Technology Facility. We are having courses start up again in January. So if you're interested in looking at some of our spring semester courses, let us know. But fall definitely would be, if you wanted to start the certificate, fall would be the time. We can kind of connect you with some of those other classes too, maybe for spring. Let us know, give us a call, 216-4409. And we're also going to do a really quick version of this too. So we can also give just a minor quick tour that you can also share with your friends and family. All right, take care. Thank you. Wait,